In this section, we're going to be talking about hypothesis testing for two means. So sometimes, instead of looking at how a population parameter compares to some known or accepted value, we instead wish to compare two population parameters to each other. In this case, we're interested in whether the two population means are the same or whether one is larger or smaller, or simply not equal to the other. So in this case, we will be performing a hypothesis test for two population means, mu1 and mu2. We will still follow the same basic hypothesis testing steps that we've learned already. The formal hypothesis testing procedure means that we choose our null hypothesis H0 and our alternate hypothesis H sub A. We decide upon or find in our problem the significance level alpha that we're using. We then compute the test statistic and the p-value, which is what we are going to be using Excel for. And then we compare that p-value to alpha in order to draw the conclusion and interpret those results. So for two sample tests, the hypotheses look a little bit different. So our H sub naught for a two sample test can look like the following. The big key is that the H sub naught always has some sort of an equal to sign. So we are either saying we assume that the two population means are exactly the same, they are equal to each other, or less than or equal to each other, or greater than or equal to each other. So I'm going to go down to these special notes to talk about that right now. So again, right there it says the H sub naught always includes the possibility that the two population means are equal, or that there has been no change. Okay, so the alternate hypotheses are the complements of these null hypotheses. The H sub A never includes an equal to sign. So you can see that those corresponding H sub A's are not equal to, greater than, or less than. The opposite or complement of whatever the null was. The type of test that it is named after the H sub A. They're named after the alternates. So notice a two-tailed test is named for the not equal to sign. The right-tailed test, it's called a right-tailed test because the alternate has a greater than symbol off to the right. And the left-tailed test is named for the alternate of saying, no, we think it's less than. So just notice that, be careful about that, because these types of tests, the labels, they go with the alternates, not with the null hypotheses. So under our last special note down there, it says sometimes the hypotheses are instead written with subtraction. So just depending on where you look, again, what text or what video you see online, you might see these hypotheses written two different ways. So as an example, if we have the H sub naught being mu1 is less than or equal to mu2, that is the exact same thing as if they were to rearrange this by subtracting this right-hand side over. This is the same thing as saying mu sub 1 minus mu sub 2 is less than or equal to 0, right? Because then there's nothing over on that right-hand side anymore. We've subtracted whatever was over there away, and now there's nothing there. So those are just two different ways to say the same hypothesis. The alternate that would go along with that could be mu sub 1 is greater than mu sub 2, or if the text or video or whatever resource happens to like this other form of writing it, it might say mu sub 1 minus mu sub 2 is greater than 0. These are just two different ways to write the same thing. If we are saying that the first one is less than the second one, that's the same thing as saying, well, if we were to take them and subtract them, we would get something less than or equal to 0. There's two different ways to look at it, two different ways to say the same thing. Oftentimes, when you are doing your problems, it ends up easiest to pick out the alternate hypothesis from the wording of the problem and then choose its corresponding null hypothesis. So a lot of times we're going to start here and you're going to choose one of these three based on the wording of the problem, and then basically we will follow that backwards to decide what our original null hypothesis would be. Sometimes those nulls are not just blatantly clear from the posing of the problem, so we can kind of just work ourselves backwards.